This is the AB calculus prep session we had last Saturday, November 21st. And the section that I was teaching involves the relationship between P, V, A, which is position, velocity, acceleration. And the third problem we looked at was this one, that we have two runners, A and B, run on a straight racetrack for 10 seconds between t equals 0, t equals 10 seconds. The graph above, which consists of two line segments, shows the velocity meters per second of runner A. The velocity meters per second of runner B is given by the function v, defined by v of t equals 24t over 2t plus 3. And of course, t would be in seconds, and the distance would be in meters. So, part A, find the velocity of runner A and the velocity of runner B at time t equals 2 seconds. Well, if we look at runner A and we go up to 2 seconds here to the first line segment, we can come over here and get a velocity of about, maybe about 7 seconds, or 7 meters per second rather. But we're asked to find the exact value, because that's what's being asked. Well, what we're going to do is find the equation of this line segment, and if we plug in 2 to that equation for the line segment, we will have the velocity of runner A. So we're going to get our slope, which we'll call m, which is going to be f of b minus f of a over b minus a. And this is, by the way, problem A. So this will be equal to f of b is 10 minus f of a, which is 0, over 3 minus 0. So what we get is we get 10 thirds. And that's going to be in meters per second. Okay, meters per second per second. So that's our slope. And our function is going to be v of t is equal to our slope, which is 10 thirds, times our time. So therefore, if we have v of 2 seconds, we can plug in the place of t, 2. So we have 10 thirds times 2, which will equal 20 thirds. And we're going to indicate units of measures. This is going to be meters per second. Now, that's going to be for runner A. Now, runner B, and that's going to be, we're going to use our function here, v of 2 is equal to 24 times 2 over 2t, which is 2 times 2 plus 3. And so that's going to be 48 over, and in the denominator we have 2 times 2 is 4 plus 3 is 7. So that's going to be meters per second. And so we have runner A and runner B we have units of measure. It so happens that I'm interested in comparing their speed. So this runner A is running at 6 2/3 meters per second. Runner B looks like she's running at 6 6/7, because 7 is going to be 49 over 7. So this is just 1/7 short, so 6 6/7. So runner B is running just a shade faster than runner A at 2 seconds. B, find the acceleration of runner A. Well, the acceleration of runner A, acceleration of t, is equal to v prime of t. And what that's going to be is it's going to be v of t is 10 thirds t. So we're going to have 10 thirds. And that's going to be meters per second squared. And if you look at our first problem we worked out the slope from this line study. We have 10 thirds meters per second, or meters per second squared. Now, for runner B, okay, this is, by the way, part B. For runner B, we want to find the acceleration. So we have, again, A of t is equal to v prime of t, and that's going to be equal to, in this case, our low, which is 2t, plus 3 times the derivative of the high, which is 24, minus, I'll put plus there, minus the high, which is 24t, times the derivative for the low, which is 2t, and all over 2t plus 3 squared. And simplifying out, we have v prime of t is equal to, we have 48t plus 72 and minus 48t over quantity 2t plus 3 squared. And that's going to be equal to 72 over 22t plus 3 squared. And I'm going to come over to the left. I'm going to work below here. Below. We have v prime of 2, since we're interested in the acceleration of 2 seconds, to be 72 over, let's see, 2, that's going to be 7, right, squared, which is going to be equal to 72/49. That's going to be meters per second squared. So we have velocity, acceleration runner A, acceleration runner B, proper units of measure. This also is from the calculator portion of the test. I did not use the calculator at all for this section of the test, but we'll show you that I used a TI 84 Plus calculator and calculated this. It just took the derivative using math 8 and putting in the function and evaluating it 2. This is the decimal equivalent of 72/49. So you can just write this in 3 decimal places, 1.469 meters per second squared, and get full credit. So anyway, this is that third problem worked out. Good luck, and thanks for viewing.